Hello everybody. So today we are doing another physics problem, and this one has to do with potential energy. And the problem states that a 1500 kilogram roller coaster car starts from rest at a height 23 meters above the bottom of a 15-meter diameter loop. If friction is negligible, determine the downward force of the rails on the car when the upside down car is at the top of the loop. So we have a couple of things here. We have mass, we have the height from the top and the bottom of the loop. And we know friction is negligible, and we want the downward force. And we also know that this roller coaster car is on Earth. That's important. So for this problem, we need to know that the loss in potential energy is equal to the change in kinetic. They kind of go hand in hand. And the reason we need that is because we can use potential energy to find the velocity of kinetic energy. So gravitational potential energy, the formula for that is mg delta y. So it's mass times the gravitational constant times the change in y, which we know is 23 minus 15. And that is going to be equal to our kinetic energy formula, which is 1/2 mv squared. So plugging these numbers in, we want to find velocity here. And the reason we want to find velocity is so we can find angular speed. And the reason we want to find angular speed is so we can find the forces down here. But for right now, we just want velocity. And we get the velocity is 12.52. And this is in second, of course. So now we needed the velocity so we can find the angular speed. Because we need acceleration for forces. Because force is equal to mass times acceleration. So we find the angular speed using this formula, RW squared, which is equal to velocity squared over r. So therefore we have velocity that we just found squared over the radius, which is 15 divided by 12. Division sign, my bad. And then that acceleration is 20.9 meters per second squared. If we assume that up is positive, so if up is positive, negative F rail, because the force of the rail is down, minus F grav, because the force of gravity is down, and technically it'd be negative F rail plus negative F grav. And then we have, this is equal to negative mass times acceleration, because that is also downward force. So F rail is equal to ma minus F grav if we move this all over. And then we just plug in and solve. The force of the rail is equal to the mass times the acceleration of the cart minus the force of gravity, which is the mass of the cart times 9.8. And we get that the downward force on the car when it is upside down is equal to 16,635 newtons. And that is how you solve this physics problem dealing with potential energy.